Hey guys, it's Miss Landry here, and today we're going to start learning about life. And we're going to start really small. So we're going to start at the size of an atom. And throughout the year, we're going to get bigger and bigger and bigger until we get to the biosphere. So today we're learning about atoms and chemistry. Everything in the universe, including us, including the air that we breathe, including the water that we drink, is all considered matter. And matter is made up of atoms. Now, to determine if something is matter, there's two things it has to have. It has to have volume, so it has to take up space, and it also has to have mass. Now, mass is a little bit different than weight. A lot of times people think, oh, well, the mass is 10 kilograms, and so you're thinking of it in weight. Well, when we measure the weight of something, what we're actually measuring is gravity's effect on the matter or what it's made up of. So matter, for example, if I went to the moon where there's very little gravity or no gravity, the matter wouldn't change. Only the weight would change, which is gravity's effect on matter. So they're all made up of atoms, okay? And atoms are kind of like Legos. I want you to think of atoms as Legos. The term atomos was coined in the 5th century BC. So this was long before we knew much about anything. Like we didn't have microscopes, we didn't have any way to really look into what things were made up of. But Democritus said he termed these things atomos, meaning that everything is made up of something that is indivisible. So it's the smallest piece. So think about Legos, right? When you're building something with Legos, you have the basic building bricks, and you can have a 2x6 or a 4x4 or a 2x4. Those are like atoms. And when you put them together, you can make lots of different things. And so we're going to learn about how those things come together. But we have to understand why they come together. So we're going to start with the basic structure of an atom. So let's take a look at this. Do you see these gray circles in the middle? So these are called neutrons. So what we're talking about now are subatomic particles. Sub means below, atomic means atom. So this is below the size of an atom. This is what makes up an atom, okay? So you have these little subatomic particles called neutrons. And I need you to know for the 3 subatomic particles, you need to know the name, where they're found in the atom, their charge, and their relative mass. And we call it relative mass. You'll see why in a sec. So a neutron is neutral. So that's kind of easy to remember. It has a mass of 1. We're just going to call it 1 relative to the other subatomic particles. Notice these little blue circles. These are protons. Now, protons actually have a charge. These are positive, okay? So they have a positive charge. They have a mass of 1 also. Both the proton and the neutron are found together in something called the nucleus of the atom. So all of those protons and all of those neutrons are going to be found in the nucleus. And then in this kind of field outside of the nucleus, it's almost like a cloud outside of the nucleus, you're going to find the electrons. Electrons are negative, so they have a negative charge. They have a mass relative to the neutron and the proton of 0. Obviously, they don't have a mass of 0, but it would be like if I got on a scale and I was measuring my weight. If I took off a ring, it wouldn't change the weight of what the scale was reading. So the mass of the ring is about like the mass of the electron, if that makes sense. So it doesn't actually add to the atomic mass. This is what it looks like right here. Oops, sorry. Let me go back. This is what it looks like. So if you notice, I can ask you how many protons there are, how many neutrons there are, 4 and 4, how many electrons, there's 4. I can ask you where is a proton found? It's found in the nucleus. Where is an electron found? It's found in the cloud outside of the nucleus. Okay. Now this, on the left-hand side of this screen, you have your periodic table. Now, Dmitry Mendeleev is the one who came up with this, and it is absolutely brilliant. There's so much about the periodic table that when you start to learn all of the different things that you can know based on the periodic table, it's like you're let into like this secret society. It's pretty cool. But I wanted you to just be able to read the periodic table and get some basic information. Okay, so we're going to look at carbon. So here's an example of what you would see for an element. So the symbol is right, it's the letters. It will only be either one capital letter or it'll be a capital letter and a lowercase letter. I am going to be tough on you guys because if you write, for example, let me get a pen. Let's say that you're talking about cobalt, which is, where's cobalt? Cobalt, right here. I like cobalt because it's like Colorado, right? So it's CO. Notice it's a capital C and a little c. That's cobalt. If you guys write both capitals, that's a very different thing in chemistry. That's carbon monoxide, and that's deadly. So I'm going to be tough on you guys when you write your symbols, that you make sure to write them correctly. Okay? So the element symbol, then you have the element name. The element name does not always match the symbol. So for example, let me get, if you look at gold, right? So gold, its symbol is AU. Silver is AG. We also have potassium is K. So sometimes the names come from either where they're found. It could be the person who discovered it. It also could be a Latin or Greek name. So don't assume that the name and the symbol are going to match. This top number, it's always going to be the lower number, is what we call the atomic number. The periodic table is actually organized based on the based on the atomic number. Now, the atomic number tells you a couple things. One, it tells you the number of protons. So if I look over here, I can look at tin, which is right here. I see the atomic number of 50. I know it has 50 protons. It also tells you the number of electrons if the element is neutral. And for the most part, assume it's neutral unless I tell you the charge. So I know that tin, again, has 50 electrons and 50 protons. And I want you to notice how it's set up. As you go across the periodic table, each next element increases by 1 proton. Okay, so if you notice, 1 proton for hydrogen, 2 for helium, 3 for lithium, 4 for beryllium, 5 for boron, so on and so forth. And then the final number that you need to know is this number on the bottom, which is, I'll move myself over, it's the atomic mass. So this, remember when we looked at the picture of the atom, all of the mass was in the nucleus. So basically this is the number of protons plus added to the number of neutrons. So I can actually figure out, sorry, let's clear that. I need to go back. Oh my God, I am really struggling. Guys, hang on. Okay, there we go. So if I need to know the number of neutrons, I can actually take this atomic number and subtract the atomic mass from that, right? So picture, let me give you an example. So if I said to you, if you notice here, I have how many, sorry, I'm just trying to move this, hang on. Why won't this move? There we go. If I asked you how many protons are in this carbon atom, you already know it's 6. If I ask you how many electrons are in this, oh my gosh, I'm sorry, guys. If I ask you how many electrons are in it, I didn't say anything about it being charged, so you can assume it's neutral, so it's also 6. So it's 6, 6. And then it says how many neutrons. And this is where you take the mass and you're going to round the mass to a whole number. So 12.0, 0 would keep it at 12. And I'm going to subtract the atomic number from that and I get 6. So this one also has 6 neutrons. So that's how you figure out how many subatomic particles each one has. Okay, let's clear this before we move on to the next. Okay, let's practice a few. We're going to practice these, see how we do. Oops. See how we do. All right, so here's a question. I am asking you, what is this little positive subatomic particle here called? That is called a proton. Remember, protons positive, P equals positive. These right here in the nucleus are neutral. Do you guys remember what those are called? Those are called neutrons. And then we have these little, let me move me again. We have the little, oh my gosh, I am really struggling. What is this negative subatomic particle outside of the nucleus in a cloud? That is called the electron. So we have protons, neutrons, electrons. And what do we call the center of the atom where all of the protons and neutrons are? That's called the nucleus. Let's try this. I want you guys on your notes to go ahead and write down the answers to these, and we will go over them in class. So I have 3 elements here. I have calcium, lithium, and boron, and I want you to write down on your worksheet what is the name, the symbol, the number, and the mass of each 3, and then you're going to figure out how many protons, electrons, and neutrons. So good luck, guys, and I'll see you later. Thanks.